Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review area. So let's start off with this shape here, a square that's 1 meter by 1 meter. It has area 1 meter squared. But of course 1 meter is the same as 100 centimeters. So this square actually has area 100 by 100, which is 10,000 centimeters squared. So that means 1 square meter is actually 10,000 square centimeters. Now we know that there are 100 centimeters in a meter, but there are 100 squared or 10,000 square centimeters in a square meter. When you are converting square units, so like millimeters squared, centimeters squared, and all that, you need to also square these numbers called the conversion factors. So everything here gets squared. So for example, if I have 0.8 kilometers squared and I want to convert to meters squared, I'm just going to use this chart. So going from kilometers squared to meters squared, I need to times by 1,000 squared, which is actually 1,000,000. So 0.8 kilometers squared actually is 800,000 meters squared. So you can use this chart here to convert between square units. Remember the rule that when you're going from a smaller to a larger unit, you divide because there are fewer of the larger unit. When you're going from larger to smaller unit, you times because there are more of the smaller units. So area is just basically how many of these squares fit inside a 2D shape. So a lot of it is about knowing the formula, which are in your notes, so make sure you do that. We're going to look now at finding the area of some composite shapes. So let's have a go at finding this shaded area here. So the way we can do that, we can find the area of the whole shape. This is a sector, so part of a circle. It's like a slice of pie cut out of a circle. So sector minus triangle leaves the area of the shaded part. So let's first find the area of the sector. I'll call that AS. So the formula for area of a sector is theta over 360 times pi r squared. So why is that? Well, pi r squared is a full circle, but of course a sector is not a full circle. This here is only 45 3/60ths or 1/8 of a circle. That's why we have to times the area by 45 3/60ths or 1/8. So in this case, theta is the angle in the middle, so I'm going to replace theta with 45 and replace r with 13. So putting this on our calculator, you might need to put the time symbol in between in your calculator. We get 66.3661. I'm going to use 4 decimal places here because I need to use this number in a subsequent calculation. I need to subtract from this the area of the triangle. So let's now go and find the area of the triangle. It is an isosceles triangle. Now we don't know its perpendicular height. We need that to find the area. So fortunately, though, we can use Pythagoras. See, if a triangle is isosceles or equilateral, you can divide this triangle into 2 congruent right-angled triangles. Because these 2 triangles are congruent, they're the same, that means that this here will be half of 10, it will be 5. And of course we know that side's 13. So if I call that h, I can just use Pythagoras to find its length. It's just longer side squared minus shorter side squared, and putting that in the calculator, we actually get 12. The perpendicular height of the triangle is 12 centimeters, and therefore the area of the triangle is going to be base times perpendicular height divided by 2, which is 60. So of course, the shaded area that remains that we wanted to find, it's just going to be sector minus triangle. It's just going to be 6.37 centimeters squared. I've given my answer to 2 decimal places. Make sure you use units. All right, let's look at this shape here. So this is actually a trapezium, and a parallelogram stuck together. So this time, rather than subtract, we're going to add their two areas together. So let's look first at the trapezium. So trapezium's a four-sided shape with exactly one pair of parallel sides. So the formula for the area of a trapezium, I'll call it AT, is h over 2 a plus b. Just make sure you know the formula. So in this formula, h is perpendicular height. In every formula in measurement, whether it be area, surface area, volume, whatever, h always means perpendicular height. So the perpendicular height is 8. Now, for a trapezium, these little a and b, they refer to the two parallel sides. So it's going to be 9 plus 15. So that actually gives us 96 centimeters squared. Now, the area of the parallelogram, which I'll call AP, so area of a parallelogram is just base times perpendicular height. Once again, if you see h in a formula, it always means perpendicular height at 90 degrees. So in this case, I'm going to replace B, the base of this, with 9, and I'm going to replace H, the perpendicular height, with 7. So the area of the parallelogram is simply 9 times 7, which is 63. So the total area of this shape is just 96 plus 63, 159 centimeters squared. All right, let's now look at finding side lengths when you know the area. So we're going to try this question, calculate the radius of the sector below. Now, whenever you are trying to find a side length from a measurement, so you're given the area, surface area, volume, whatever, always follow these 3 steps. Write the formula, substitute into the formula everything you know, rearrange for what you don't know. So let's do that here. So we know that the formula for the area of a sector, so part of a circle, slice cut out of the center of the circle if you like, is theta over 360 times pi r squared. Now, we are told here that theta, the angle in the middle, is 120, so I'm going to replace that with 120. We're also told that the area is 300 millimeters squared, so I'm just going to write 300 millimeters squared here. So that's step 2 done. I've substituted. Now I'm going to rearrange. See, I want to know what r is. So I'm going to undo what's been done to r. So the first thing I can undo that's been done to r, it's been times by 120 over 360. 120 over 360 is just a third. So the way you undo timesing by a third is to divide by a third. Or if you like, the way to undo timesing by a third is to times by 3. I'm going to times this side by 3 and this side by 3 because a third times 3 is just 1. They cancel out. So I'm then left with 900 equals pi r squared. Okay, how do I get r by itself? Well, BIDMAS tells us that r has been squared first because it goes brackets index. Index comes before multiplication. So r was squared first, then it was times by pi. Because this is the last thing done, it's the first thing I undo. Just like in the morning, you put on your socks, then your shoes. At night, because the shoes were the last thing put on, they're the first thing you take off. And so it is here. So timesing pi was the last thing put on. It's the first thing I undo. What I'm going to do is I'm going to divide each side by pi. Now, I'm not going to round this because I need to use this number in a subsequent calculation. I'm just going to leave it as 900 over pi. That is the exact value. So r squared equals this. The way we undo squaring is, of course, the square root. So I'll get the exact answer by square rooting 900 over pi. I didn't round this number here because that would introduce an error into my calculations. So this is the exact answer. If you're asked to give it to 2 decimal places, you just put that on your calculator. It's about 16.93. Now radius is going to be millimeters since our area was in millimeters squared. And then we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.